Hi, my name is Bob Greenyer and I'm a volunteer with the Martin Fleischmann Memorial Project. So welcome this Sunday, the 1st of March 2026, when I will be discussing O-Day, Matterwave interference. So how is everybody out there in YouTube's land? Hello, Overwound Games. Alex Del Castillo, Joseph Collar, Low End Drop C, wonderful. Melifury, Moon, Mookster, and Stone W1H are in the house. We also have a regular in the form of Gordon Docherty, thank you for joining us, and Artifact, thank you, respectively from the UK and Germany. Chauxis over there in Australia, and we have Misunderstood 432. Where are you? Are you in the UK or are you in the Mediterranean? Who can say? Brandon B, Donovan Nagy 4303. Wow. Hi Ken Pratt over there in the States. Hi Todd Hall. Yes. Hi Rotus over there in Australia. Wonderful to have you here. Nick Moore again in the Midlands. Wonderful, Midlands of the UK. Hi, and Ian McKellen, Silo Jade, Daz Pizzazz. How is everyone? How is everyone? Well, I have some proof for you, some incontrovertible proof that I get things wrong. You know, I said last week that I was going to go and speak in Italy at the ICMNS conference. Well, I went. Yep, I went. Very tiring. Had everything ready. Go to register on Monday this week. Went into the building. No one there. Went into the building next door. No one there. So I did find some people behind the counter in the sort of, city technology center main entrance, and I said, I'm here to register for this conference, but I don't see anyone here. So they said, show me, and so I showed them, and it goes, yep, it's a Monday, yep, it's the 23rd, but it's not the 23rd of March, it's the 23rd of February. Okay, so there we go. I have proved categorically that I can fail epically. So one must laugh at oneself and accept this. So I was therefore stuck in Italy in a hotel room, which was very, very small and extremely basic. I wasn't expecting to spend any time in there whatsoever. On the plus side, I made use of it. I finished the second to last of the papers in the book. It was a gargantuan task because there was no decent source that was easy to recognize, and I had to find these various negatives, which were some in color and some completely the wrong color, and I had to color adjust them and get them all merged together. Anyway, it's looking very beautiful. There's only about 20 pages left for me to remaster. It's all been proofread apart from about 2 pages. So that's good. However, in the process of meticulously looking through thousands of slides, I found an absolute gift. In fact, a couple of absolute gifts from our good master here, the dearly beloved and parted Takaaki Matsumoto. And I'm going to show that to you now. But first, I'm going to show you what I think it is also representing. And of course, this is very, very interesting to me because where we saw it was in the Bin-Juen Huang et al. Cavitation reactor, one of my favorite demonstrations of the wheel within a wheel structure. And this time it's in this experiment, which is not that. It's a 1-point cold fusion experiment. So one of these lead wire explosions. I think it's circa 1997 to 1999. I think I'm going with 1998. I'll be able to confirm that. But I think it shows exactly the same phenomena. Slightly represented in a different way, but you will see what I mean in a few moments. Okay, so just give me a second. I'm going to bring up the relevant slides that I want to show to get this point across. So, as you know, I have this rather, he says, have I only got the single slide? I might have more than one slide. Okay, have I only got the single slide? No, it's all in there. Is it going to play when I ask it to play? Yes, okay. 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 So this is the slide in question, and it's not Munchen's Scream. It is, I believe, a sideways strike of a large apple-shaped structure that then deposited its two progeny, and as the thing collapsed and then broke away, the progeny go out in the reverse direction to the way they came in, and gave us our two substructures. And one of those two substructures, which I would call the yin, because it has pressure within it, gave birth to a yang and a yin. So we talked about this last week. And so the next, oh, sorry, I was going to press play there and I didn't. So as we move through this sequence, this mouth shape here that starts in the small here under your lip and goes up to go within the center of the mouth region. This is a increasingly lower density of the physical vacuum, and so as it's approaching the phase singularity, there is an increasing gravity and increasingly depleted or fast moving neutrino clusters. So matter in this area gets over energized and destabilized and pulled into the vortex. And one might think that when this was still, overall structure was still active before it spat out these two structures, it was the cone interacted up to this point, and then it doesn't interact because of the way that this sits 50% into the material. Okay, so it produces this kind of like teardrop shape in reverse, going into the vortex, into the phase singularity. And as we've shown before, we have this x to 1.618. So that is the top of the apple to the center, and from the center to the center point of the point of destruction, the initial point at which matter starts to fall apart. That's 1.618. It's 1.618 on everything. If we draw a circle with a center point here to the radius there and draw it around, and then we do a circle and divide by 1.618, and then another one 1.618, another 1.618, then this is the golden ratio vortex into the center. And again, basically the whole thing has golden ratio everywhere. Anyway, and as we go on, we have our n-1 and n-2. So that is the base reference image that I want you to hold in your mind. And I'm now going to pull up what I am referring to here. It's two different images from the Matsumoto archive. Now, I actually need to go and rescan these using the very high quality Epson scanner rather than the basic Kenko slide scanner, because we're going to get far more resolution and fidelity out of it. But the first of these I got extremely excited about, because we have two breakup clusters, and they look remarkably like the breakup clusters that you see in the lead wire experiment that we did, which I will be looking at in more detail at Elia Foundation on the so-called MFMP SEM on Thursday this week. So we're going to see a lot more of this data. But you can see here you have a polygonal sort of inside focused area, this with a roughly off-center center point. Then this boundary here And then down here, we've got two fuzzy balls. And unfortunately, I can't go back into nearly 30 years ago and ask him to try and take a different image of this. And whilst he took this, he never discussed it. Again, over here, we have another similar structure, an internal structure with a pole, some material around the outside. It's broken up more. And then we've got one substructure here and one substructure here. This excited me. This excited me. And so what I did was I looked around those images in that same data set. And I found another one here, which is slightly different, but a more flattened out, broke up one. But the real money shot for me was a different one, which I'm going to find for you now. And it is here, I think. No, not that one. This one. Okay. And there you go like that. So I'm going to go full screen so you can see it in all its glory. Okay. So here we have the one that was also within the same series of images. And we have our central area here with a sort of bled pole. And then we have this next layer here. And this one looks like it's crashed in this way, whereas in the Binger and Huang, it crashed in from the side. This looks like it crashed in more this way, and it spilt its guts out here. And it looks like we have two structures here with some inner structures. And over here, it looks like we have some structures with some substructures within it. So just to overlay the sacred geometry, we will start here. So I am arguing that these two here are our yin-yang that have been spat out. And here's the yin-yang of the yin-yang that's over here, these two. Like I say, I want to confirm this by going in and looking at this in a bit more detail. These look like they're trying to get out over here. If they were central, they would be like that, and you can see how that lines up. And this is actually how it works. And so these are orthogonal, and those are orthogonal to that. You've got to bear in mind that whilst they're spheres, it's not necessarily the arrangement of the tores in there. Okay, because they are spheres, so you can arrange the tores because they make a sphere in the non-radiating boundary. Okay, so it's something along those lines. So this crashed in here. The inner shell kind of went up this point, but you can see that effectively this is almost the exact radius of the structure that's on there. And that these two in here spat out over here. And that over here, if I take that off, that one off, and go in and move that over to where they are, they came out and they are currently here. So they're almost getting out, but they don't quite make it. And so this for me is a hidden gem in the Matsumoto materials that is not in the book. But shows that within his 1-point cold fusion, which he has a paper which he also didn't publish, and he called it My Favorite Experiment. And that is the experiment that gave birth to this image. And it is those kind of experiments that are representing or producing this kind of structure and this kind of structure and these kind of structures. Okay. So that said, I am going to try and explain why I have got this on the screen in a minute when I do. This. Now, this actually is not a real photograph. This is not a real photograph. This is a contrivance of several different bits of AI that I used based on a template that is a real kind of layout. But this isn't real. So, what is it based on? Well, let me get this for you. It is based on wave interference. It is based on wave interference. And so I will get the particular site that I'm looking for. Okay. So, can we do it in there? I think we can do it in there. No, we'll do it in here. I hope this is going to work. Let me know if this is very slow for you, because I don't know if we've got our internet working very well still. And that is a no. Okay, this is going to be tedious. Okay, all right, no. Okay, so here. It's this site. I'll include the links later in the blog. But it's at British Columbia Yukon Press Books, University Physics Volume 1. Interference of sound waves. Now, if you recall, I did an interference pattern that I believe is in the coherent, or rather the standing waves inside the Griffin-Brock tube. And we have sound wave here, which is equivalent to ion acoustic waves here. And this is a place of rarefaction, and this is a place of compression in pressure waves. And you get three types of interaction with these systems. You get an interaction of two minima here, which is constructive. You get the interaction of a maxima and a maxima here. And here you get an interaction of a maxima and a minima. So this is constructive in the positive sense, this is constructive in the negative sense, and this is destructive, whereas one wave might destroy another. Okay, and there's a more complicated one here, which you can see. And you can see that it's saying here on the blue spots here, blum, 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 blum. There are two crests, and they are purely constructive. Here on the red spots, you have two troughs, and they are purely constructive. And where the black spots are, these are purely destructive, which is one crest and one trough. Okay, so early on in the work of John Hutchison, he had a colleague working with him. I forget his name right now, but John, if he's in the chat, might like to chime in. He had an idea that the Tesla coils and the big toroidal donut structures he had at the top of those were producing these waves, which you could consider as scalar waves potentially if they have phase and antiphase, 180 degrees out of phase conjugation being emitted. But where you had the interference of those, that is where you got some action going on. And we know that from the ultra experiments that is exactly the case. And I've argued that this is what is going on in all of these systems. You can do sound waves on a surface, sound waves in a volume, ion acoustic waves in a volume. And when you want to go into a volume, you need to have both a neutral cluster and you also need to have traveling, ideally, phase conjugated waves, and maybe you want phase conjugated waves, but you want them to interfere within the working volume. Okay, so I took this image and I created a base image from which I constructed what you had just seen as a so-called piece of geometry in the sense of, oh, have I actually got it? Did I save it? Did I save it? No, maybe I didn't. Ah, that's annoying. Oh no, I've got it here. So let me go back to there. Let me go back to there. I've got the wrong image up. Let's bring the right image up. Okay, so if anyone wants to know how I did this, I will let you know exactly right now. So here is our image. But what we're actually looking at is this. And that is the image scaled and overlaid. If you want to take the blue spots off, I did that. And so we get 2 ion acoustic wave patterns. And as I explained last time, or the week before last, no, last week, when you have a complex interference pattern of not only electron, you've got ions as well as electrons moving forward and back at different speeds, depending on their level of ionization, depending on their mass, and depending on whether they're an electron or an ion in that system. And you've got these flyby-Bernoulli effects and all kinds of stuff going on. But at the very basic level, you have these areas, and where the pressure waves are most intense, going from positive to negative in a standing wave fashion, that is where you get the matter most compressed. Okay, and so these are the relative nodal positions here, and this is the one that I chose to show you. But what I did was I used this as a guide with Photoshop's AI tools, and specifically the one that's useful actually is Google's Nano Banana 3.5 to create the ones that you see here. And it wasn't just that. I asked it to also create a marble dome. This takes quite a bit of time, but what I was asking it for is to have things that are embossed and other things that are debossed, or rather, should I say, things that are coming out and things that are going in and things that are not doing anything. And it couldn't quite get it, and it missed bits off here, so I ignored it. But it was interesting that it decided to put all these things in here, and it's rather pretty. There were some ones that were a bit more of a miss, still pretty in their own right. And so to get architectural ideas that are based on this kind of understanding in the future, there's going to be a lot of opportunities to use generative AI to lead to physical objects. Okay. Anyway, this is the one that I settled on. And the reason is essentially that if I group those two together, it's going to make it easier to show. Blah, blah, blah. We're going to do that, and we're going to do that. Now, this will all make sense as to why I'm talking about this in a little while. I can do that, and I can now turn that off. No, I've still got one in there. Okay. All right. So, yeah, so where we've got red spots, we've got, how should we put this? We have lions, red spots. There's a lion everywhere. There is a red spot, and that's constructive troughs, a trough and a trough meeting. And then where the lines cross over here, we have the constructive crests, and where there is no lines crossing and no troughs crossing, we have the destructive things. And unfortunately, they're not differentiated. I was trying to make one, but I thought I'm not going to waste too much time on it. It's fake anyway. But you get the general idea. You might like to put some window in there rather than having this coming through here. And it's not perfectly symmetrical, and so what? It is what it is. Okay. All right, so that's that. Now, why am I doing all this? Why, Bob, are you doing all of this? Well, as you know, I have argued that the Aharonov-Bohm effect is created by the fractal toroidal structures, creating a phase singularity where matter is pulled in, but also forced into coherence, so that each matter type, be that a relic neutrino, a proton, a atom isotope, whether that be aluminum-27, or say copper-63 and copper-65. In every case, all of those different matter waves will be forced by the Aharonov-Bohm effect to become coherent matter waves. That is, centripetal de Broglie waves. I'll say it right. Centripetal de Broglie waves. And that is where the wave description of the matter folds in upon itself so that it doesn't destruct itself. So that it does not destruct itself. And I thought the best evidence for that was the 1998 paper by Dubovik and Afanasyev. It's actually almost a book, and I've given reference to that in many presentations. You can go and look at and download my Strasbourg presentation where I give the link to that. But I purchased this a couple of weeks ago and it came through. And this is Lecture Notes in Physics by M. Peshkin and A. Tonomura on the Aharonov-Bohm effect. Now, I am not going to read this, learn all the equations and throw equations at you. Do not worry. However, at the back of this book, it talks about all kinds of experiments that led to the proving that the Aharonov-Bohm effect is real. And it comes down to, essentially, a superconductor producing a vector potential around a toroid and a magnetic field in the core. Okay? And this proved that in the center, and this is the kind of device that was used in Japan, okay? And toroidal ferromagnet covered with niobium layer. I think niobium has the highest spin. Interesting. Layer, scanning electron micrograph, and cross-section. So it was super cooled and so on. And they had a whole bunch of sequences there. And what they show is the phase shift of the electrons in the center. Okay? So this is the scale. It's a very small little superconducting supercurrent loop. But basically what this book tells me, the basic things that you really need to know, is that when you have a superconducting ring of electrons, then it will produce the Aharonov-Bohm effect in the center. It will also produce a magnetic core at that center. And that is exactly what is produced by a fractal toroidal electrodynamic structure in each and every one of at least minimally a wheel within a wheel within a wheel structure that we saw Matsumoto generate in the late 1990s and we produced in the core of Huang reactors. Okay, this book was published in, and I kid you not, it was published in first edition 1989. Yep, 1989. There you go. In fact, the preface for this book was written in, so presumably the book had been finished in 1989. The preface was written in March 1989. And as all of you know, that happens to be when Pons and Fleischmann announced their findings. Okay, so the superconducting electric loop, and in fact it has here, it has an explanation here. It says, so it's got it here. You have supercurrent, superconductor. There's a supercurrent in the superconductor, but there's a magnetic flux going through the center. Okay, and so you have a matter wave of electrons, and in this case it says otherwise the Cooper pair. So it says when the wave turns once around the magnetic flux and returns to the original position, the phase has to be the same as the original value modulo 2 pi. Okay, and that gives you your centripetal de Broglie wave of a Cooper pair of electrons. That is a boson of electrons. Okay, and what it says is but it says basically, otherwise the Cooper pair will vanish and the superconducting state will constantly revert to the normal state. This means the phase shift, delta S, integrated along the closed path around the magnetic flux should be precise integral multiples of 2 pi, i.e. 2n pi. However, the phase shift, I'm not going to say all these equations, it's not necessarily equal to 2n pi. Then, does the superconducting state break down? Actually, no, it says. Cooper pairs prefer to preserve the superconducting state by producing a supercurrent. The supercurrent flows near the inner wall of the hollow torus, so that the total magnetic flux, i.e. phi, plus the magnetic field induced by the supercurrent is equal to n open bracket h over 2e. Although there seems to be many possible choices for arriving at quantized flux, only the quantized flux closest to phi is automatically selected to determine n. So basically, this produces a state in which the Cooper pairs, the centripetal de Broglie waves of electrons in this case, will allow themselves to not destruct each other. And this will produce a magnetic flux through the core. This is like the cell kind of basic start. One Cooper pair producing a situation which essentially produces the Aharonov-Bohm effect. So one single pair of electrons can start to produce the Aharonov-Bohm effect. And this experiment proved it in, let me just check when it was. I think it was prior to 1989, but it was in Japan. There was a lot of debate about it for a long time. And the book's quite nice. It goes through all the various different experiments. So in 1986, interestingly, about the same time that Ken Shoulders was publishing Evie, A Tale of Discovery. So there we have it. So you start building these things up and you are going to get the fractal toroidal electrodynamic structure, which again will have an Aharonov-Bohm effect in the center. And this has been known about and proved since 1986. Okay. All right. So why am I still going on about this? What is your point, Bob? I want to know. Okay, let's get to a little bit more of the meat of what I want to get across today. Okay. So, they know that I'm going to present some aspects surrounding this. And so some of the things that I'm talking about today, I was to present this week, but now I'm presenting it next month. But because I had to go through the process of thinking about it, I want to get it out the door and for people to have, a chance to ruminate on this, what I view as the next step of the process. The first thing that is really important is that it hasn't been enough for the community to accept that Matsumoto's image here and similar things that we have generated ourselves here, where my daughter, when she's coming up 11 now, but when she was 8, she could see that all of that could not fit in there. All of that could not fitted inside that, right? And that tells you that something has to be going on in this, which means it can fit in there. Right, so I want to ask you a question whilst I'm maybe preparing something over here. What, and don't cheat, I want this to come and be coming out of your head, please. I don't know whether you're cheating, so do we like? Anyway, what element has the highest density at standard temperature and pressure? What element has the highest density at standard temperature and pressure? Yes, it's a quiz. What do you think has the highest density? And then I will get what I want. Not lead, no. Not titanium, no. Not mercury, No, not lead. No. The highest density. Not tungsten? Yes. Curtis Horner's got it. Did you cheat? Come on, you can tell me. Osmium. Osmium. No. Listen to Curtis. It's osmium. Unobtainium. No. Stable element, fractal friend. Okay, so it's osmium. Okay. There is one other element that is denser in certain circumstances. What is that? This is a harder question, if you don't know. Curtis, can you be first on that as well? Can you be first on that? I'll give you 5 more seconds. 5, 4, 3, 2, 1. No, he's not boron. That's not very dense at all. Okay. Curtis one's going to sit this one out. He's already sitting happy on the first win. Very wise. Quick whilst you're winning. It's iridium. Iridium under certain circumstances and phases is denser than osmium. But osmium is the most dense matter. Now, I'm going to mess things all up right now. But I want you to think. What is denser than osmium? What is denser than osmium and iridium at all potential, or if one considers all potential conditions? What is denser than osmium or iridium given Carmelium? My pocket is dense. I didn't say deep. I said dense. What is denser at any temperature and pressure? Neutron stars, yeah. What is... That is not a bad answer, actually. That's your brain, Marty Angel. I don't think that's true. Come on. Me. Shockwave says it's me. Professor Dave. You know, I might agree with you on that. I think my job here is done. Everyone knows it's Professor Dave. Come on. Metallic hydrogen, maybe, no. What is denser than osmium or iridium in certain circumstances is coherent matter. Coherent matter. Bose-Einstein, thank you very much, Algaz. Coherent, very good, Eldex Del Castillo. It's almost like I'd said it. Very good, coherent matter, yes. Coherent matter allows you to park density into the same space-time. Okay? Now, that's cheating, John Coombs says. Why is this relevant? Well, as you are aware, when the matter gets pulled into our structure here, in this core, matter can be phase cohered, and therefore you can get matter occupying the same space-time. Okay? Yes, Gordon. Boson formation. Can either be a boson, or it can be formed from 2 fermions. Okay? Now, yeah, so that is density. Now, you might have heard Ashton Forbes talk about Farris-Williams and the so-called 5th dimension. What are the 3 dimensions, and what is the 5th dimension? What is the 5th dimension? Do you know what the 5th dimension is? Do you know what the 5th dimension is? Corky's going to have to defer. Corky, come on. do not listen to poor Ashton. Ether? Vacuum? Ether? Time, space-time? No, we've already got... what? Okay, starts... Calm down. Biofield? No. Okay. Let's start with the 4 we know, right? Or that we accept. What are they? There are only 3 dimensions. Well, Cartesian, yes. Normally, I would say Shockwave has got the 3 strict dimensions, X, Y, and Z, right? To define volumes. Okay. Oh, Michael Vodanilich 26 has got it. It's matter density. Yes. And the fourth dimension is time. So space-time is X, Y, Z, T. That is 1, 2, 3, 4 dimensions. And Farris-Williams added this other dimension called matter density. Okay? Now, where do we have matter density in our, or controllable matter density in our toolbox? Where do we have controllable matter density in our toolbox? Are you getting where I'm going here? You kind of do. What you do, Diane Tai says interference points. Yes, because it is at certain of the interference points that you get more mass collecting and less mass. Now, if the whole system is in a coherent matter state, then in some areas of it, you would get more matter density, and in others, you would get less matter density. And in fact, what is coherent matter, like a Bose-Einstein condensate? Bose-Einstein condensate is converting the quantum, okay, I hate that word, but the probability of a particle or a nucleon or a nuclei or even an atom being in a piece of time, space-time, when you try to observe it, right? And so it's like the probability distribution function of an electron is these lobes around a nucleus or a sphere for the 1s and so on, these different lobes. That is the probability distribution function. And it's only when you observe it, collapse the wave function, do you observe exactly where it is in that particular probability distribution. A coherent matter wave or a Bose-Einstein condensate is the collective wave function of where a number of atoms will appear at any point in time when you collapse the wave function, i.e. it decoheres from the coherent state. And you can have more mass in different areas at different times. Okay, so in this particular structure that we have been looking at over a long period of time, you can achieve ordinary matter density outside the non-radiating barrier. Inside the non-radiating barrier, after a boundary layer which is replete with substructures that are similar but on a much smaller scale to the macro substructure which is holding them out, you will have a different space-time density in these areas, 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 and certainly in the core. You will have a gradient of space-time matter density in the sub-vortices, the sub-sub-vortices, and in the main core vortice. Okay? So you could argue that this is the key structure, for instance, in a nuclear detonation. In a nuclear detonation, you have space-time matter density because you have a bulk magnetohydrodynamic structure often, and it is replete with trillions of substructures of various levels of self-organization. Okay. And I will run through these slides, which I've done many times before, but essentially in the patent of S.V. Adamenko, for his controlled nuclear synthesis process, he shows a 5/9 pure copper plate. A copper pin target has been hit with a 300 joule disruptive discharge, and it synthesizes all of the elements in the periodic table, but this is the only SEM he chose to put in his awarded 2003 patent. and it shows an iron-rich sphere with a perfect, it's broken, it has a perfect sphere, again, hemisphere in this case, broken inside. And he argued in a 2005 Ukrainian newspaper that he thought the nuclear reactions, which he says occurs in an electron nucleus nucleon macrocluster. And he says basically there's no atoms in there. And he argues in his book that periodically stable nuclei form and they are ejected from the cluster. So if there's no real atoms in there, what is a macro electro nucleus nucleon macrocluster? What is that? What is it comprised of? I would argue it's a whole series of coherent matter waves, a whole series of centripetal de Broglie waves. And they have all kinds of space-time matter density within them. They're all being controlled by their own little magnetic flux, and they're all in their own little universes. And this will be important, that phrase. I've discussed it before, but they're in their own little universes. Oh, sorry, little galaxies. The whole structure, I would argue that this whole thing here is like a universe. And in here, you will have had many different little galaxies in there. Okay. So this is what he said. This was transferred to Illinois, and George H. Miley verified the technology, wrote several papers on it between 2017, I believe, maybe 2015 and 2021, maybe as late as 2023, and it's part of the National Fusion Program. So we've created the iron crenellated microspheres, and third parties have. This was Me356 in 2016, although he couldn't tell that this was iron, but it likely is based on this being carbon and the fact that these appear. This was in 2017, experiment that I did in Hungary with Nova experiment in August 2017. Obviously in the Ultra experiment, we produced the yin-yangs and the toroidal donut bubbles, but they led to, in Alan Goldwater from Magic Sounds experiment, these iron-rich crenellated spheres, which are hollow. But this is where it really starts getting interesting. And I've never really discussed this before, but I think now is the right time. In so many systems, and if for those that remember, in the late Neil Crichton Gould's nickel, diamond, deuterium oxide experiments, we saw the diamonds being eaten away. And in one case, there was a tube coming out of the hole in the nickel where the former abrasive diamond particle was. There was a tube. How does a tube form? There were other areas of diamonds where sections of the diamond had been consumed, and in the place was a glassy sphere of carbon. We also found that there were, when we analysed the copper oxide on the outside of the structure, or the reactor, we found that when we were looking at that under the SEM, we found that we were seeing the copper and the oxygen and the copper and the oxygen, and suddenly something would happen and the copper and oxygen would disappear from the analysis, and it would show 100% carbon, and then it would go back to showing the other elements that were there, including the alumina and stuff that was underneath. And this is called Schrodinger's K-at, C-at. And at the time I didn't fully understand it. I believe now that that is because clusters were still, that were replete with carbon inside, were stably stuck in the copper oxide. And when we hit it with the 15 keV to 20 keV beam of electrons, it overexcited them and blew them up, and it spilled their payload. Okay. So what is glassy carbon? Well, here you can see here this material here and this kind of fog that you get on the outside. Okay. And this has clearly come out of this structure here. One of these iron-rich crenellated spheres in a Vega experiment. And you have this glassy deposit down here. Now, in many cases, we have observed these tubular carbon-rich structures coming out of these iron-rich crenellated spheres, or within the reactor. In the 225-day reactor of, that's a nickel-hydrogen reactor of Dr. Alexander Parkhomov, we saw these little carbon tubes. We saw them in the core of Lion reactor. We saw them in the thunderstorm generator, including in close proximity to iron-rich crenellated spheres. This here is one signature of the coherent matter being in the core. Films, thin deposits, and glassy forms of carbon are again a signature of a very fast collapse of a coherent matter structure. So what you're seeing here, in my view, is a deposit of collapsing coherent matter. It is a signature of coherent matter becoming decohered. Again, when we had indium, HHO from Amasa gas on the indium, it glowed as bright as the sun, despite the fact basically indium. Actually, indium, I think, is just, it's almost as dense as osmium. And it's weird because it has such different properties. Osmium's like really high melting point, very, very brittle, hard. And indium is like soft. But I chose indium for those experiments in Japan because it's got a lot of long-lived beta isotope in there. It is able to be activated by real neutrons. And it is the lowest melting point metal that doesn't ignite and burn ordinarily easily in air, like things like magnesium and stuff like that. So I chose that. And when you put the HHO, the Amasa gas on there, even though it was 75 micron thick, it turned to jelly and did not extend. It almost immediately did a Hutchison effect on camera. And then it glowed like a tungsten filament light bulb. And then you saw these jets coming out. These explosion jets. And when you look at that under the SEM, you can go and look at my poster session from ICCF 22 in 2019 in Azizi. You saw the exact same plume of material erupting like from literally things that looked like volcanoes. And one of them looks almost identical to this. And it was full of like carbon, oxygen, and silicon. And silicon is the fusion of carbon and oxygen. Okay, so this is, in my view, definitely a signature of coherent matter coming out of these processes. And if you take this is essentially 85% carbon atoms and nearly 13.5% oxygen atoms. So of this deposit coming out is, you know, basically 98 nearly 99%. Well, you can work it out from down here. So it's 98.5% approximately, 98.4%, 98.3% roughly of this matter is just carbon and oxygen. Of course, sulfur is double oxygen, okay? And the copper and zinc is probably actually just being seen through. So what happens when you fire an electron beam from a scanning electron microscope? Some of the electrons have a high enough energy to penetrate the material if it's just on the surface like this that you're trying to analyze, and it's actually seeing returned characteristic X-rays from the material underneath. So it's quite likely that the copper and zinc, and some of the oxygen, to be fair, that you're seeing here is coming out of that. In fact, the majority of the oxygen. It could be the case that almost all of this material coming out is carbon, potentially even 100% of it. And in that case, that is essentially the same claim as Matsumoto was saying there. But when it spat out all of this carbon, what we see is this material, two toroidal donuts emerging from inside, okay, or apple-shaped structures. And they are rich in aluminium, which is an exchange reaction between carbon and oxygen going to aluminium and hydrogen, low concentration, and titanium, which is up to 21% by weight there, and down here it's 22.3, sorry, no, over here rather, it's 11.3%. But anyway, this structure here predominantly is still carbon and oxygen, but it has this atomic concentration of 7.655 of titanium. Why is that relevant? Well, that is the fusion of carbon and oxygen in the form ratio carbon CO2. CO2. Of course, in the thunderstorm generator, we see it here. We see it here in the thunderstorm generator. This is the hollow crenellated sphere, small one from the thunderstorm generator. You can see it's hollow, this broken one. This is from the Hwang reactor, VCS5RT. This is in optical imagery from VCS5RT. This is in scanning electron microscopy. Now, in this one, I got a sense that there were toroidal clusters in here that were piled in. Now, if you go way back to the ultrasound in water in 2017 that I took in Suhas Ralkar's lab in India, you saw these vortex solitons coming out, and if one was coming behind and it was a small one or whatever, it would shoot in from the back and it would go into the center, and basically it would disappear to all visual purposes. So these structures will suck things up their arse and they will become part of the Borg. So I would argue that in this case here, substructures are either created by this thing and all the turbulence in it go round and come back in, or are created somewhere else in the environment and are pulled in. This is iron and oxygen, and given its color, this must be lighter elements because of the way an SEM works. And so this will not be as heavy as iron and oxygen. And since it's starting with water, it's likely to be things like carbon and oxygen and things like titanium. Okay, so again, Hwang reactor 41B here, different reactor. Again, this is from 41B, and we see in this golden ratio in a high concentration of iron and lower concentration with iron and oxygen on this cluster that is broken up. And you can very clearly see toroidal substructures in here. And for me, these are little expanded galaxies. These are little expanded galaxies that are in here. And what you have in here is darker grey areas and lighter. So the lighter an element is seen in this type of view, that means it's a heavier element. So we know this is iron. You're going to see it on the next slide. This is mostly carbon, and the bit in between must be a heavy element. What is that heavier element? Well, in this image, I'm showing just iron, titanium, and copper. So we don't want to look at the oxygen. You can see the inner area is very highly concentrated in iron. That's the 1.618 here area on the outside is less concentration of iron because this is more oxygen in it. Okay. The copper is all the way around the outside because it's a copper pipe, very highly discriminated. And then titanium is only in the structure in the core. Now, it isn't all of it, because when we look at that material, I've got a sample point here on this, where I show it here. It's on this part of this part here of this donut, okay, of this donut from the core. We look at it, and it has carbon, nitrogen, and oxygen. So you get a nitrogen from exchange reactions or protons getting involved in the CNO cycle. You have predominantly carbon and oxygen, but skewed towards oxygen. And when you look at the atomic concentration, this is bordering on a CO2 ratio. And that, in my view, makes it favorable to go towards producing titanium. And you can see by weight, this is 22, nearly 23% titanium. And then you've got the intermediaries of silicon and aluminium, which are, I would argue, this interaction between coherent matter standing waves. Okay, so if you take carbon and oxygen and fuse them, you get silicon. If you could take carbon and oxygen and fuse and fission, you get aluminium and hydrogen. We don't see hydrogen in a SEM. If you take CO2, which is the kind of ratio we're seeing here, we produce titanium. Okay, so this is the product you're seeing in there. And I want you to focus on the fact that it is globules of titanium in a matrix of carbon and oxygen and nitrogen. Globules in little cluster, toroidal clusters. Okay? And this will become clear as we move further down. Now, I talked about this, of course, if you change the phase angle of a fractal toroidal structure, in this case axial hypertoroidal moment, it can either be a ring up to an apple and even up to a sphere. So both Ken Shoulders and Matsumoto observed these structures either as circles to spheres, and this is why, in my view, obviously we saw these things here, that's going to show me here, and here. I won't go into those. We saw them emerging. We saw this material. We saw this material. But in this one here, where you see this braided structure emerging from an overall broken up structure, this is its payload that was inside. And you can see a loop at the top here and maybe another loop at the top here. But you see this braided structure. And again, these lighter spots here will be titanium. Thank you very much, Skoggy. Very much appreciated. These lighter spots here will be titanium. The intermediate areas will be carbon and oxygen, and there will be other elements to a lesser degree. But there are these open areas. Now hold that in mind. I'm going to go and find something else for you. It's on the blog. You can go and look at it in a second. And let me just find this for you. File. Yeah. And what do I want? Oh dear, what was it? My brain. Not enough sleep. Okay. What am I looking for? Well, it's coherent matter standing waves, traveling waves. So, yeah. I talked about this last time, and this is a patent from, I started this blog referring to the Lockheed Martin patent, systems and methods for generating coherent matter waves. There's this prior patent from the Max Planck Society, and it produces an atom laser as an output beam. And all I did was I colorized one of the figures in the patent. The reason I colorized it is to kind of match what we actually physically observe. So this is a synthetic, I don't know whether they used a mathematic process to produce this. And what this does, it produces extended blob beams of coherent matter that can be ejected. And what they use is they use a quadrupole trap and another type of trap which is elongated, and they use laser and magnetic cooling, and then they change the magnetic structure and they fire out the blob of coherent matter as a coherent matter wave. A coherent matter wave, which, because it's coherent matter and it's a coherent matter traveling wave, it is an atom laser, i.e. it's coherent matter of atoms. A coherent matter of atoms. And so when you compare it to this image, which I composited together and shared for the first time on August 2021, also in a conference in Assisi. Let me just make this full screen. Oh, it says it's really big. It's a really big image. So there's several things here. Okay. We have 1, 2, 3, 4 frames in a David Boutlier Vega experiment over in Canada, and it perfectly ties up with a repeating pattern. Okay, this is the influence of a coherent matter traveling wave on a stainless steel plate in Roy Schneemaser's vibrator plate, again with a repeating segment here. And this is a collapsed coherent matter wave globule, okay? And it has 1, 2, 3. It has repeating geometry in there. This, my friends, is basically carbon diamond. And if you have each atom average energy in the coherent matter condensate, when that collapses, if the kinetic energy of those atoms are over 20 eV and the confinement is still, or rather the coherence is decaying in a certain way, then rather than getting glassy carbon or a film of carbon, you will get diamond. You will get diamond. And the first time we saw diamond was on the nickel copper Constantan wires of the first experiments we replicated of Francesco Celani. And we observed diamonds forming on those copper and nickel treated Constantan wires. And there was no explanation for it. I would argue that coherent matter clusters, which were what we observed, and we called you can go and look at the old quantum heat website. You can go and see that the matter wave, the radiation we called gamma back then, because we didn't have any other explanation for it, was likely these structures coming out when we were recharging with fresh hydrogen. And so this here is a little bullet, and you'll notice if I take out my mugshot here that up the top side, at the bottom and the top side, where is it? It has like this is actually a very high resolution image if you download it. Let me go and have a look again. Come on. Play nice with me. Okay. It has a little tail off. This for me is the last little bit of coherent matter, and then there's no more in the traveling wave. And that is the same at the top end. It kind of leads in, it goes into this wave pattern, and this is the last little dying part, or it's the other way around, one or the other, okay? And this kind of basically dies at this point. It could be because the coherent matter wave is going either into the surface or out of the surface, right? Here is one produced in an ultra experiment, and it's breaking through the aluminium. This is the wall of a yin-yang structure, so you can actually see it here. That is the one of the two. So you've got a vortex twirl coming through at this point, and here you've got another one. The vortex is going around this way. This is a cone with a pit, and over here, this part here, you can see I've blown it up here. You have something coming from the other side, penetrating the aluminium and leaving this little blob here. And when we look at that up close, that little blob, my friends, is not the material we started with, okay? So, can I do it that way? I can do it that way, but it's not allowing me to show. Oh dear. Maybe if I do it. There we go. What do we got? This is a different blob, but of course it's here. It's all kind of like one mixture of material. It has copper and zinc in it. It has all of these different elements in this part, and the background is basically aluminium. Okay, so I believe there are a couple of examples. Now, what is so interesting to me about this is that it is open cell. How does a diamond form in a braid like this? How does a diamond form in a braid like this? Well, it's basically asking the same question as to why we are having these braids here, and I've shown you braids in other experiments, but why are we having braids here and open areas here? Why do you think that is? This is a question for you guys. Why do you think that is? Why do you think that is? Anyone know? Anyone have a guess? Yes, MF Lauder. Varying space-time density. Varying space-time density. But more than that. More than that. I'll give you a clue in a minute. More than that. Phase conjugation, yeah, you're pretty much close there. Nodes, yes, Alex del Castillo. Yes, yes, yes. You could argue that if you had two matter waves interacting of carbon and carbon, you would get the production of magnesium. Now, when I was doing the research for my presentation that I'm going to give in the CC, no, not in the CC, in Italy last week, or rather this week, but it's now going to be next month, I found out that no one has ever created or claimed to create coherent matter wave of many different atoms simultaneously in the same space-time. But that is what these fractal toroidal electrodynamic structures does. Yes, 63 Charlie, matter wave interference. You read the title of the presentation. Well done. It's matter wave interference. Yes. Matter wave interference. And in fact, what I believe is happening, and what I believe we have got all the physical evidence for, and let me see if I can find you a relevant slide. A relevant slide to demonstrate that we have got all the relevant physical data we need to show what we are seeing is what we're seeing. I think this slide kind of sums it up. You will have seen this slide before. But most importantly, this image down here of a Masa gas on tungsten. At the point of destruction, the tungsten is disassembled. There is a wave here that comes in and up here. Why? It's a wave because it's rotating this way and then it's rotating back on the other side and then it's rotating this way. So it produces a wave. This under analysis, which I have shared, is a carbon film. Why? Because the mass density gradient here is disassembling matter. It's falling apart. And we can only see carbon here because carbon is a solid when the matter wave collapses. But if the matter wave, for instance, was oxygen or was, for instance, alpha particles, then aka helium with an electron, then they would go away. So we're not going to see those when we see the thing destroyed. But I think what is happening is let's say dark matter is coming in, it's overexciting, there is a vacuum energy gradient because we know the phase singularity according to the 1995 paper of Schwerblis. The wheel within a wheel within a wheel within a wheel produces a vacuum current that is able to capture photons, and since it can capture photons, it can capture all of the photons, which means it can capture all of the 0-point energy photons. And if any matter, including relic neutrinos over which light travels in form of clusters, is pulled into here and it increasingly accelerates into here, you have a space-time matter density gradient into the core and the sub-cores. And matter will get unstable and fall apart and come into here. And then you have in the core a electron, nucleon, nuclei, and possibly in the core of the core, electron, quark, gluon, plasma. And this is also in S.V. Adamenko's book. And there's no real definition of what these things are. Now, I need to go and see if I can find it in a presentation I did called Magic Incarnate many moons ago, because there was a structure in a Hutchison sample that was like a cone, like a black hole, like you see those classical wormhole one side of those pictures, and it had a shelf on one side, and it was made of elements, and then it had different elements in different levels of interference pattern on it in the analysis. And that's the first time I saw this interference pattern. I thought, how on earth do you get these things mixing together? For instance, how with Emarza gas or Brown's gas do you get aluminium welding to iron? How is that possible? I'll tell you how it's possible. How this is because you are producing coherent matter waves, and when the music stops, the elements appear when the music stops. And so they're intertwined with each other. You're able to produce alloys that are not possible in any other way than through the interaction of coherent matter. Okay, so that is what I'm saying. And what is happening is, let's say you had aluminium and you had a coherent matter traveling wave going around your yin-yang structure. You can imagine that on one side, it might destructively remove an oxygen atom. Let's say, how would it be there? Taking it away here and then maybe adding it over here. And I can tell you, when I looked at George Hathaway's sample of the fragments of a Hutchison bar that had broken, I exactly observed the same observations he did. These arrays of dots, and I suspect that they might be the interference of some scalar interferometry of scalar waves in the material. Now, what is happening, therefore, when you see these structures which I showed you just a few moments ago? That is to say, what is happening when you see this effect going on? If I can find it again. Yes, this one. What is happening when you see this? What is happening when you see this? What is happening? What is happening when you see, where is it? Over here. What is happening when you see this? Well, I believe what is happening is that the interference between the matter waves and the density of the probability of an atom appearing in each part of the matter wave centripetal de Broglie wave allows for interaction. And what do I mean by that? I mean, they're not expressing their charge. They're not able to express their charge. They're a coherent matter structure, a Bose-Einstein condensate, but there's lots of them in there. Now, they don't occupy the same space-time, the atoms. The waves don't occupy the same all the way around their centripetal matter wave, their centripetal de Broglie wave. They don't occupy the same space-time all the way around. But at some points, the probability function of an atom appearing at a particular point in time, in space-time, when the coherent matter collapses, is higher than, and might appear, for instance, a carbon atom might appear at the same position as an oxygen atom. carbon atom may appear at the same position as an oxygen atom. And if the nuclei appear after the matter wave collapses in exactly the same location, then there is no Coulomb barrier. It doesn't exist. No Coulomb barrier. Forget the Coulomb barrier. Love it. It's gone. Okay? And what you get is a silicon atom forming. You get a silicon atom forming. Consider two coherent matter structures, and they are somewhat overlapping, as you literally see inside of the cluster that's broken down from the Huang reactor. You literally see donuts like intersecting each other. I've shown you a macro structure intersecting. Imagine those are two centripetal de Broglie waves of a coherent matter of oxygen. I can show you this one. This is probably good enough to get it. Right? Imagine these are going on in the core. So there's definitely an interference between those two. But also within the core that I showed you earlier, and is it in this one? Yeah, it should be in this one. Is it in there? Yeah, this one here. Some of these toroidal donuts are definitely looking like they might be interacting with each other, or they might be interacting with each other at the point of collapse. So if you've got two, for instance, oxygen atoms interacting with each other, you would get sulfur 32. Two oxygen 16, two sulfur 32. If you've got oxygen 16, oxygen 17, sulfur 33, oxygen, 16, 17, and 17, 17, sulfur 34, right? If you've got a proton matter wave, so the protons would have to form pairs and form a centripetal de Broglie wave of a proton coherent matter condensate. If you had that interacting with the oxygen 16, at the point at which the matter collapses and they're overlaid with each other, then you would get oxygen 17 forming, for instance. And why is this relevant? Well, matter is constantly flowing through this point. It's cohering and so on, and then some of it goes through and comes around. Okay? Well, this gives us a very clear explanation for what is happening here. It gives us a very clear explanation for what is happening here. Because here, when two nuclei appear at the same, two nuclei appear at exactly the same space-time, the Coulomb barrier goes away and you get what's called the liquid drop model. There's different ways of thinking about this, but basically the strong force takes over within a field over which it can operate, a range over which it can operate, and the two nuclei fuse together basically instantly. The strong force is like strong. It says what it is on the tin. And what happens on a literal boundary here, on the boundary of this piece of diamond here, is there isn't enough strong force, for instance, to keep it bound together, or even molecular force, depending on what's going on here. And what gets produced here is, let's say, oxygen or helium, and that just goes away and it leaves it open cell. So this exactly is a representation of a collapsed coherent matter wave structure. That is what is happening here. Probably in these areas, oxygen was formed, or helium was formed, or argon was formed, and it went away. Because if you take two titanium-47 and you fuse them and fission them, you get argon-38, as observed in Benjamin Huang reactors and observed in Modenese and Gambarali. And so that will go away, and you get the carbon and the oxygen here, and where the carbon and the oxygen matter wave interact, you get titanium. Okay, so titanium is a solid, the carbon bound to the oxygen bound to the titanium, or the carbon just closely matched. You know, it could be a hydrocarbon if there's hydrogen in play, but we can't see that in SEM. And it could be carbon dioxide, but it's somehow bound, carbon monoxide or whatever. But anyway, it's carbon and oxygen here and titanium. So that is kind of what I am saying. Now, something has happened in the last couple of weeks which is very, very interesting. And I'll see if I can pull up the image. So, no one has ever publicly admitted to creating incident, collective, multi-isotope or element or electron and element isotope or nucleon coherent matter wave clusters. But I think we've been doing it all the time we've been doing this research. The Coulomb barrier is completely irrelevant to this process. The only place it comes into is when the highly energetic things in here can't form a solid state, or even if they're too energetic and they're not, that you don't have two nuclei interacting in the same space-time so the strong force takes over. What you have then is when the coherent matter wave collapses, those nuclei that are not able to co-locate and synthesize a new element in the form of constructive, or separate and form two other elements or substructures in the destructive or interference regime, there will be elements that are formed back into the non-coherent state, and they might have gained a lot of energy from the overall coherent condensate from the nuclear reactions that have gone on. And these are highly energetic, so they will be expressing that kinetically, but moreover, they will start to instantly express their strong force repulsion, their Coulombic repulsion. So you will get an explosive event, what will look like a plasma flare, okay? But they are atoms that are extremely cold. That is to say, they have no kinetic thermal energy. They're just being repelled by the Coulomb force, by the charge. And for me, this explains a number of things, and I will say it now. When you have that boat in the Hutchison effect, and it's being treated with his frequencies under his conditioning field, it is building up using the phase conjugated and interferometry standing wave nodes on which these topological monopoles are aggregating matter from the environment and cohering it. And when you turn off the frequencies that bind these things into a state where they are continuing to build and locked into position, they then explode with this cold explosion which produces plasma. I mean, it literally glows, and you see these things moving around the surface because they're now not trapped on the interference fields. Then, if you are looking at samples where you cut open a Matsumoto sample, or you are looking at a cut sample, which I've showed many moons ago, of a Hutchison effect, and you see these spherical chunks taken out of inside a piece of steel, that is because the standing wave node structures were consuming the material around them, and when the music stopped, you had different elements there. And some of the coherent matter may have gone into clusters that became neutral and just came out of the metal. And so it was lost to the mass of the metal. And so when you take this to its logical extension, you have a complete understanding of how you could dustify something. You charge it with scalar interferometry. It produces the topological monopoles. The topological monopoles are then able to eat the material around them, whether that be on the surface of something or it be within the metal if the scalar interferometry is in fact scalar waves rather than electromagnetic interferometry. Okay, you could also do it with targeted sound. Sound leads to vibration through a structure, and that would actually lead to this process going on. And in fact, Cardone was able to cause transmutation in metal just by vibrating the metal. And you got these points on the metal, and they had the signature ring spot type structure. Okay. And so you would energize it. And what you're doing is you're winding up a spring. You're winding up a spring. Basically, all that matter and energy is condensing into space-time matter density in the phase singularities of the fractal electrodynamic structures that form these topological monopoles, which have these supercurrents. The supercurrents maintaining the stability of the centripetal de Broglie waves, the matter waves in the overall structure. And when the music stops, the thing just falls apart. Because these little voracious little beasts that have been spun up to eat and consume any ordinary matter. Remember, they have a non-radiating boundary that gets replete with miniature structures that are capable of consuming any form of matter. Any matter. This is the densest matter. It has a higher binding energy than all ordinary matter. And so it can consume anything. But when the scalar interferometry is there, they're locked in place. They are little beasties all the way through a matrix of the thing that you want to interact with. When you switch the frequencies off, boom, they set to work, and it starts to consume. It starts to consume. So, and then you get the things coming out, right? Now, I should have probably done several booms in this, but I'm going to be preparing for a boom, so see where I'm going with this. And I want to find this image if I can. Let me see if I can find it. Not there. And ba-dum-bum-bum. All right. Have I got it? Maybe not there. Excuse me, bear with me. Right. So we have one working shadow graph producing structure. Griffin-Brock Desmotron tube here in the Czech Republic. One of the ones that I brought over from my trip to meet him and do the radionuclide remediation last year. This one is the one that I showed the standing wave in. What has been observed by Jan is when he is looking at the what I'm going to actually do is I'm going to I don't know if you can see it here, but can you see that there's little scintillation spots on there? Scintillation spots. I've got a close up here, I think. There. These are scintillation spots on the iPhone. Scintillation spots on the iPhone. And when you look at them closely, they are, I've got another couple of images here. These are various close-ups on the scintillation spots. So, what does that mean? Well, an exploding EVO can produce up to 10 keV electrons. They can produce up to 10 keV X-rays. They are not sufficient energy to go through that air and cause scintillation on that sensor. This implies that it is producing neutral exotic vacuum object clusters and that they are coming out, and this is basically why it's remediating nuclear waste materials. And this is when, as they go into the phosphor, they are getting trapped and they emit their energy in there, producing the light in the shadow graphs. So we're getting a very consistent picture here. what Shishkin, Karols and Dubovik found in their 9 years of research within Dubna, the nuclear city north of Moscow, is what, and I shared a translation of this presentation from 2018, in 2018, is that when you pass what at the time they were calling magnetotor-electrical radiation, which they say is the same as exotic vacuum objects, and they now call energy solitons, when they pass through other nuclei or other matter, they take on the bare nuclei of that other matter, which means they are stripping all of the electrons off and they are capturing, and I would argue, intercoherent matter waves condensed into the core. Okay. It's easy to understand that in the 3.6 trillion volts per meter on the leading edge of even a single pulsed laser into a nonlinear plasma, you are going to get all of the atoms, electrons stripped off. So there's no difficulty in realizing how you just get the atom nuclei trapped in the phase singularity of these structures. They have also shown, and I shared this work, where they took either an electrical discharge or a exploding foil in a chamber with either moist air or hydrogen, so a source of hydrogen. They had a optical fiber around the outside, and they passed that optical fiber into a glass chamber with a a microscope slide at the bottom. Where that light fiber came into that chamber only contained CO2. It only contained CO2. They sent me something where the laser was coming into that CO2 filled chamber, and down on the microscope slide, it had a white deposit. They sent me some of that white deposit. I have shared the analysis of that. It had a high concentration of aluminium. As I've said before, you take carbon and oxygen, you fuse and fission, and you get an exchange reaction where you get a proton and aluminium coming out at the other end. Okay? This is phenomenal. Why? If we have a system which can produce vast numbers of predictable coherent matter wave clusters, energy solitons, that can grab any particular atom that you want and make it into a coherent matter wave inside its nuclei, then you are able to capture that flux that we're seeing on that iPhone sensor into the standing traveling waves in a laser. They used, like, I think it was a 5 milliwatt laser or whatever laser. It was just a laser. It wasn't anything really fancy, passing it through an optical fiber. This is effectively what's happening in the Hutchison effect. He has traveling waves of microwave energy coming through an environment that he has either uranite producing charge clusters or a disruptive discharge in a large searchlight producing charge clusters. It's the neutral ones you want, and you guide those on the traveling standing waves into your target. And you phase conjugate if you want it to go into the material. Okay? If you have a system where you had 10 Griffin-Brock tubes and they were outputting neutral charge clusters, and the neutral charge clusters had to pass through particular element stocks, and then the laser captured those, you could then print not only you could print atom by atom using atom lasers, as shown in, thank you very much, Black Tie, as shown in the slide I had from the Max Planck 1998-1999 patent for creating these blobs of coherent matter. Not only could you deposit individual atoms, that if you got the phase accurately, potentially, and broke up those clusters correctly, You may even be able to interfere atom matter waves to skew the atoms being formed to the atoms you want synthesized, which you don't have in your atom lasers. You need to think of this like a 7-color printer, where you like choose 7 elements, and from those 7, it might not even be that. You might just need protons, alpha particles, carbon and oxygen, and maybe you could create almost everything you want. And you could literally use matter wave laser. And this is literally what Charles Chase, one of the authors of the Systems and Methods for Creating Coherent Matter Wave patent, which was the first blog item on Remote View. It's what I built all of this off. He envisages being able to print things with matter wave lasers. He envisages that. So we potentially have a system where by interfering these things in a chamber, we could create any element we want. And then by passing more of the neutral clusters through that matter wave interferometry, you could capture the synthesized elements that you want to deposit in another matter wave laser that you can then direct with pinpoint accuracy. And if you had some sort of ultra advanced CT scanner that scanned a perfect burger, what you did was you hired the best Michelin star chef that had ever existed, or exists rather, and you get him to come and make the best burger that can possibly be made with the best taste and the best juiciness and the best whatever, and you do a kind of like advanced CT scan of the positioning of every single atom in that burger, and even the kinetic energy of the atoms in that burger, then technically I can see a time when practically it will be possible to create any atom you want, and then to capture those atoms and direct them and print them at a specific energy such that you create a replicator. We have such an amazing and bright future ahead of us. And it is things like this that tell you how it works. Copper being sucked in. This is a dual vortex structure. You will see this kind of vortex structure in some of these wonderful tornado images that are coming out, where you have kind of like a vortex on the outside, but you have a central core vortex. This is a copper slug being sucked into this magnetohydrodynamic structure. It will take anything you will give it. It'll use the hydrogen. It'll use the oxygen from the water, but it'll also use the copper. That's the foods that's available in its environment, and it's very flexible, and it breaks it down. It breaks it down into the raw materials. I mean the raw materials, as we see in the work of the HHO or Amarza gas here. It breaks it down to likely protons, carbon, oxygen, and alpha particles. It pulls it in and it reassembles it on a matter wave interferometry basis based on space, time, matter, density. Okay, and that is pretty much mostly what I wanted to say today. We're getting to the point where, and I'm having this debate with David Kidwell, formerly of the US Naval Labs. It's very interesting because 18 people at the US Naval Labs have looked at my LinkedIn recently. 18 people. Like most of the people looking at my LinkedIn right now are US Naval Labs. He says he's not working there and he's retired, but I'm having to walk him through the evidence, and the evidence speaks for itself. It's physical evidence of the process occurring. It's not particle smashing. None of that is going on, except when the thing blows up and you get these high energy versions of the nuclei thrown out. That happens, yeah, but that isn't the core process. The core process, in my view, is coherent energy transformations. It takes all of that matter, it creates a whole huge bunch of coherent matter waves, centripetal de Broglie waves in the core, and the interference of those and the matter density of the relative densities of the relative isotopes that are available to start with will lead you to a point where it'll eventually create a lot of iron, and first it'll create a lot of carbon. And then what Leclerc found is that when you, and for instance here, I'll give you another example. Leclerc saw in his cavitator with the aluminium around one of the circles a huge plume, and the plume was diamonds. It was diamonds. Why is it diamonds? Because the matter wave of the carbon that was synthesized in the reactor, in the little clusters, was at a energy level that it would form diamonds rather than a glassy carbon or dispersed carbon atoms or carbon films. It produced diamond. Okay, so I was trying to walk him through this process, that we have the physical data now to basically explain everything, and it isn't particle bashing. Yeah, of course, we've done them. You know, I've shown you what we did. We're using microwave ovens, and I will show at one of my presentations at ICONS the data from my remediation experiment, which I proposed in 2007. I finally managed to gather the materials in 2019. Then I was told by George Eagley that the guy that made the Nova reactors died of breast cancer, so I decided not to do it because of strange radiation. Now I know what strange radiation is. It still scares me, but I'm willing to take a few hits for the team, such that we get to a brighter future, because it's only through understanding these technologies we are going to have a freaking amazing universe to live in. Yeah, it can be printing, but it can also be creating the elements you need on the fly in the printer. So like it can mix the nucleons together and then use that as a basis for more matter wave lasers. Three says, Bob, why have you never connected your iron-rich crenellated spheres to the giant spheres found in Costa Rica, looking at macrocosmic emanations of this process? I kind of have mentioned it, like roughly, but very, very not like shown pictures or whatever. I don't like to talk about these things until I've actually physically seen them. I like to connect with the thing that I'm talking about, and so, you know, like. It's weird. I will show you examples of where things that we have observed occur in nature. And, you know, one of the early criticisms that was quite intense was from George Howard, when he realized that I was showing all these things on which the entire cosmic impact theory is based. And I said, well, you know, meteorites will produce these things. So will all kinds of industrial processes. And we know several of them that do. And just because nature likes to produce them doesn't mean that nature doesn't like to produce them. Nature likes to produce them means that nature likes to produce them. It's just I'm saying we have evidence that show these structures are formed very specifically in these fractal magnetohydrodynamic structures, and out of the cores the new elements are synthesized or are reborn. Yeah, again, with the super smooth vases, you know, you could argue that, you know, when people didn't have lots of ways of wasting their time, like watching 3-hour YouTube videos, they had plenty of time to sit there and polish something very slowly. And what you will find is that very important people and very revered people will always have the finest of the finest of the finest of the finest things. I'm not saying that there isn't some special technology, but I have handled those vases, those literal ones from Matt Bell. And inside several of them, they've got kind of like tool marks. Okay, the tool marks are, point to maybe something interesting going on. And of course, you've got those things on the outside, and it doesn't really make any sense. But like, just because you don't know the technology doesn't mean they didn't have a technology that we just haven't got currently. I was talking to a guy on the bus back on Friday from Vienna airport, and he was here for most of his life up until he was 33 or 37 or something under communism rule. And when he actually started to promote Coca-Cola just after the end of the Cold War, and this guy that came in to help him with marketing just continuously pointed out obvious things which were not obvious to the local population. So, for instance, during communism, at the supermarket, you couldn't enter the supermarket and do your shopping unless you had a basket. And everyone accepted this as what you had to do. So when he came along and went to a supermarket, he started walking in, and this guy that I was talking to said, "Oh, you can't do that. You need to wait in the queue for the basket." And he says, "Well, I only need 2 things, and I can carry them in my hand." And he goes, "Oh, yeah, you can just pick them up and walk and okay." And it never occurred to him. Here's another thing. He said, he said, why don't you choose a different color for your trucks? And he says, well, trucks come in blue. Because the trucks that they made were only blue. And they had different types of trucks for doing various different things, but they were all blue colored. And it had never occurred to him. So once you've seen something, it may seem obvious, and it may be that there's an obvious way of doing it only when you've done it. And maybe we haven't found that out, or maybe it's some exotic technology. I can suggest that potentially it might be something like this, not necessarily for synthesizing it in a 3D printing type way, but we know that these things can bore through or disrupt normal ceramics like alumina, like silicon dioxide, and that is basically granite, right? So I was talking about this to the team earlier today. We could literally have these fine tools, which are a beam of high intensity of just the charge clusters themselves, which can manipulate the matter and oversaturate them and allow us to abrade it with minuscule precision, or maybe potentially soften it, because the machines will be working in there, and because it's not magnetic or whatever, we can move the thing around. I don't know. We have a massive blue ocean of opportunity here for incredible technologies that just will look like frickin' magic. It'll just look like magic, and it'll be as unbelievable to most people on planet Earth now as the idea of having a modern smartphone was certainly to my mother when she was, my daughter's age. Well done, Screwdriver Tuning. Says, my ultrasonic cleaner experiment, my 8-year-old did this yesterday. Wonderful. John Coombs, maybe. The light bulb, the Dendera light. I don't know whether we need to have Muscovium. I don't know whether that's particularly a red herring. I'll say this now. I have mentioned potentially, because of its use in fusion bombs, that there might have been something critical about having lithium batteries in a so-called airliner that may or may not have been teleported or destroyed. If you go and look at my Defying Gravity presentation, you will see that I talk about spin nuclei being key and their alignment of the spin to allowing for an equivalent of focusing gravitational flux. Okay? And old lithium-ion batteries use lithium, of course, and most of lithium is the spin nuclei 7. They also use an electrolyte which has fluorine in it, and I think phosphorus. So fluorine is 19 spin nuclei, high spin. Phosphorus 31 high spin, and it also has other things in there which have hydrogen in there, obviously. So I am stating now that it is my view that if the lithium cells, such that they were, we don't know if they were actually lithium ion cells, but if they were, they would act as a gravitational focus for the coming together of the subtors in that fractal toroidal teleportation system. So I missed the boom, so I'm going to do them now. Boom, we can understand this. Matter wave lasers, coherent matter wave traveling beams. Boom, we can make replicators. Boom, we probably know how to teleport stuff or to improve our likelihood of teleporting. Yes, the Evo DAO, there's various people working on different aspects of that. I need to touch base with Charles. I know Charles is working on a trading application at the moment. That's his focus at the moment. So there's a little bit of pause, but I do know that teams are working on the wind hex and other systems. So like loads of things are moving in the right direction, regardless of the status of that. Hello, Charles. Maybe you can speak for yourself. Right, MF Lauder HC9PC. Did the Matsumoto book ever get published yet? Not quite. I will be finishing probably the last 20 pages tomorrow, hopefully. Hopefully tomorrow. And I will be getting the PDFs out, I would like, by the end of this coming week. This will be for people to tell me you made a mistake here, you made a mistake there, before it goes to print. So hopefully everyone will have a PDF of the new version of the book by the end of this coming week. How to get specific elements, Bob, like make iron turns completely into gold. Right, well, you're probably easier starting off with heavier elements that are less valuable, because you don't have to work so hard to get to the high nucleon numbers of gold. We do know that in electrical discharges in, I think, nickel sulfate with nickel in play in water, that gold was produced in the product that was a higher concentration than any deposit in the United States. And so the problem is that, you know, is that able to be made into an industrial process? Possibly, I don't know. We produce precious metals in the nickel sulfate, nickel foil production in, or rather Suhas Ralkar did, and we observed it in the analysis. So yeah, it's possible to do this, but I think with understanding that this is a coherent matter wave process and that it is this kind of interference thing, which they could say it's not possible, but come on, tell me where you've tried it, right? Because if you go and look at your favorite AI of choice, yes, everyone agrees that it's something like 1996, 1997, a coherent condensate of alkaline metals was produced. That was the first time Bose-Einstein condensate was produced. A few years later, you get that matter wave laser patent from Max Planck Institute, and then just over a decade later, you get the coherent matter, you get the systems and methods for generating coherent matter waves of Lockheed Martin. You can see the progression there, but none of those are claiming the ability to, in the same volume of space, create a whole smorgasbord of coherent matter waves and increase inexhaustibly the density, the mass density, this so-called fifth dimension of the Farris-Williams universe in a structure. And that is what, in my understanding and what the physical data shows, is going on in these fractal toroidal moment bearing phase singularities that we are producing. Adamenko didn't just make elements with mass 433 squirrel. If you go and see my, I think it's my second presentation at Marioka, presenting the life work of Matsumoto there, I discuss some of that work, and Vladimir Vysotsky from Kiev University is in the room, and I say, you made very high mass numbers, and he said, oh, yes, up to 4,000 EMU, like this. He claims that they observed mass elements up to 4,000 AMU. WP for Truth says, hey Bob, do you know why Tesla had the water tested in the aquifer under Wardenclyffe? He picked that spot specifically, connects to your work. Well, I would suggest that it would need to be replete in natural charge clusters, either captured from the environment by penetration into and capture in the oxygen dissolved in the water, or because the water somehow is cavitating in its path through whatever underground aquifer it is and source, and that is also producing charge clusters in there. Nothing as it seems 5213. I can't imagine that there's another 5,212 people calling themselves nothing as it seems. But anyway, coherent matter waves and Birkeland currents operating in the same way, I believe. I'm sure there's something similar. Yes, I think there's something going on there. As above, so below. It's all the same thing. The typical one for making gold, and in fact, there's a whole series of papers. I think there's a whole series of papers in the mid-1980s in the Matsumoto archive where he's talking about them actually synthesizing gold in nuclear reactors using mercury. So I think there's a reaction where you put a neutron or something into mercury or whatever, and you get gold out after a decay time. Oh, Ken Pratt's just said here, mercury and lead lining in a high neutron nuclear reactor. There you go. B Happy says, she says some pleasant things and then says, not sure how you sleep. Sometimes I don't. Sometimes I don't, because I'm so excited. But I'm running out of things that are impossible to do now. I mean, intuitively, back in 2017, into the end of January 2018, I could realize that all these things were possible. In part, some of that was because in January 2018, I started reading the work of Ken Shoulders, and he was stating these things, and I thought, this is a very serious guy. He must be coming from somewhere to put this down in writing in very, very small pieces of text, which means he had to have thought about it a lot. But it's very different when you actually have the physical data of how this is actually occurring. You know, it is in these yin-yang structures where you've got a standing wave and one is taken away and one is putting together. And we physically see it in the ultra experiments, and obviously we physically see it in the experiments of Huang and of Urien and Boutelier, which I shared here of the Huang one. This is a braided structure. The matter waves would have been not sufficient to lead to the production of carbon and oxygen and titanium in these parts, probably here. It might have, might have been a destructive area where you got almost nothing in some places, and in some places you got helium formed, and that just went away. And sometimes it might have just been oxygen, and that went away. Okay, I'm going to see what questions. So Squirrel says, hey Bob, did you ever see the Walter Russell creating specifically elements with water and coils? I don't know whether I've seen that specific experiment, but like, you know, we know that it is possible. We know that all elements can be created from any element. That has already been done by S.V. Adamenko. You can go and buy the book. It's called Controlled Nucleosynthesis. I don't believe that's the way. It's basically slamming matter with a very large electric hammer. I think Matsumoto's experiment is not millions and millions of dollars worth and large amounts of time investment. When we replicated, and I will be looking at those samples again later this week, this is his favorite experiment, and his favorite experiment takes microseconds to do, and it shows the principle of the process that leads to the formation of new elements. Yeah, Bruno was there, I think, a long time before. Obviously, you don't need to know how the underlying process works to know that if you, like, I believe the alchemists knew that if they added these things that created these turbulent structures, that then the magic started to happen. But you needed to bake it for the right amount of time with the right amount of ingredients for the right temperatures so that you got what you wanted and not a load of stuff that's useless. Yeah, actually, Matsumoto did use gold in some of his experiments. And palladium, platinum, wires. Thank you very much, Skoggy. Very, very appreciated. Okay, I'm just going through and see if you've got questions. So Screwdriver Tuning asked, Bob, have you looked up the old iron furnaces Center PA? No, sorry, I haven't. Thank you very much, Skoggy, again. You're very generous. The Joe Cell guy also talked about learning how to turn water into oil. Well, I argue that what you're seeing here is quite likely, in many of these cases, potentially hydrocarbon. As I said, you cannot see the carbon in there, but it might even be carbohydrates. But you know, you have oxygen in the water, so, and hydrogen, so the carbon is the interesting thing that is coming out of it. But with hydrogen, carbon, and oxygen, you really have the basis for life. I understand that the TSG kit has been built. It's not by me, but by a person in Prague that took that on. It may or may not be up in the lab at some point. What I want to do is run it for a very short period of time, then have it disassembled and analyze the internals. John Coombs asked, what do you think of the TSG's progress? I think I did all I could to help get it on its way, and I like to see it being industrialized. It's not easy thing to take a nascent idea and get it into the market, especially when it's something that people don't readily understand how it works. And it's weird because, like, when do most people actually really consider how their television screen works, or how their phone does the communications, or whatever? But, you know, the internal combustion engine is such a large part of our lives that many people consider they have a base knowledge of it. And they're taught to think that you can't achieve certain levels of efficiency. They're certainly saying you can't deal with certain things that come out, and obviously there's been this huge effort based on increasingly restrictive emissions limits over many decades, and the assumption is that if the big car industries couldn't achieve those, or had to produce systems that faked the data so they could get away with kind of achieving it, then it must be very difficult, and if they can't do it, then no one can do it. But again, it's like sometimes there are just ways that are easier, and in my view, all of the ways that are easier are based on working with nature. Literally, that's the title of a presentation I gave in Taipei one year. It is working with how nature wants to work, not trying to impose your will on how you think it should work for you. So 3 says, why haven't you addressed the Bells, Barrows, Mounds regarding this phenomena? I'm really trying to focus on helping practical applications of this technology space, which is immense, deliver positive benefits rather than weapons, which certainly are using this technology, or if they're not, then there's an amazing level of stupidity at certain levels of research institutes. But anyway, I can't believe they didn't work it out, and I don't think they didn't. Yeah, Jalapeno, nature finds a way, absolutely does. Yeah, so I liked Michael's blog this week, where he talked about sin, where he's arguing that if you translate the original Greek, it's about not missing the target, and the target is like if you set out with a goal and you don't hit that goal, then you've committed a sin. But the goal, in my view, and in his writing to a certain extent, it has to be morally sound. It's not just that you're trying to achieve a certain end. Ontologically, you're moving in a direction. Is that as you move in that direction, you carry forward everyone that played a significant role, or even an insignificant role. You make sure that they're part of the process of getting to the goal, or that you respect them on the route in kind with their contribution, or in tune with their contribution. So it's for me, like, there's lots of things that I could probably spread my time over and have no time left to do anything that is hitting the goal of taking this understanding and delivering practical applications that are minimum viable products. You know, there's several patents which I've highlighted, transcoded, reconstructed, where the patent has been awarded. Sometimes even certain jurisdictions have been using variations of the product of that patent, but it's not generally used. So Windhex for one, the Kladoff cavitator, you know, even to a certain extent, the vibration cavitators and Amarza gas, they've not been very widely used in a large proportion of the earth. And these patents have expired. And why is no one getting a minimum viable product out there? It's because they don't necessarily know what that is. They don't have the wherewithal to produce it. And for instance, some Russian people and some Scandinavian people that respectively have working implementations that are in tune with the patent for Kladoff respectively and the Frank Pelivka Windhex, they are versions that have their own design patents or their own technical know-how in production. And so you couldn't just go and buy one of their devices and copy it, because that would just be, you know, wrong and very likely illegal. So making a minimum viable product such that people could go and make it, would they make it? Because like often if you mass manufacture something, you're going to be able to make it much cheaper than the individual can make it, but the information of a working embodiment will not be lost. And so when people choose to make it, and even choose to make it on mass manufacturing, they can. But then once the minimum viable product is out there, then it's off to the races with producing a better version of each of these technologies, because there is a foundation which people can build on. And so that is the needle that I'm trying to thread. That is the goal that I'm trying to hit with the right arrow within the best of my ability. And it's just a massive collective element, effort rather. As I was saying today to some of the team with regard to the Desmotron, you know, the understanding, for instance, that I shared with them, which I intend to share with the Millennium community, such that it is, and you guys today, I only got that because people were prepared to share information with me, or because they were willing to put their ideas in a sensible form out into the conversation or into the public domain. And so it's not mine to own, as it were. So I don't want to start where basically we have another massive argument for why this is coherent matter, because when coherent matter collapses, it produces glassy and or amorphous carbon structures, which we see in so many of the emissions of these various technologies here. Here's just two examples. And that can only occur from a collapse of a coherent state. If the electrons in there have a sufficient matter density, then mass density, then and energy, you could create diamond. Diamond has been observed by Leclerc. It's been observed by us on Chelani wires in 2013. It's been observed here as, in my view, a coherent matter traveling wave, collapsed wave. And that this is exactly the same as the atom laser, but the atom laser collapsed. And the coherent matter process starts with minimally 2 electrons producing a magnetic core. This is just like the Russian topological monopole paper that I refer to so oftenly from Wisniewski in 2008. And here in 1986 a superconducting structure published in this book in 1989, the Aharonov-Bohm effect by Peshkin and Tonomura. This little superconducting ring, very small, was able to ensure a centripetal de Broglie wave of 2 electrons would form, and n electrons would form a coherent matter wave, and this would be stabilized by a supercurrent and produce a magnetic flux, and that overall structure would lead to being able to phase shift electron beams depending on various parameters. And it is this proof which precedes what I have currently been referring to in the work of Dubovik and Afanasyev in 1998. But in their case, it's within the fractal toroidal moment structures. Free Life Test says osmiridium. Close. Is that a metal compound, or osmium and iridium? You just having a laugh. Yeah, so then we talked about how using this matter wave interference, for which I had my cover slide here today, here, and that was after several iterations AI generated with the assistance of Photoshop's AI tools, based on this sound wave interference, where you have constructive interference of troughs, constructive interference of peaks, and then you have here destructive interference of a peak and a trough. And that some of these will lead to fusion, some of these will lead to one taken away from the other, and it's a bit weird to think about it. And some of these the whole mass will have increased energy from any collapsed, nuclear reactions that take place, and they will express that energy upon breaking of the structures. But what this means with the scintillations that I showed that have been observed coming only from the working shadow graph producing Griffin-Brock tube, which has demonstrated, it would seem, the production or the ability to remediate nuclear waste. Therefore, it's very likely to be energy clusters. It produced these scintillations, which you can see here on the iPhone image. I zoom into that, you can see these various scintillations here. Okay. I mean, they almost look regularly spaced, and we'll have to investigate that themselves, but fairly regular that way and this way. But anyway, that might just be the frame. And blowing into that, you can see here these scintillations. That we do what Shishkin's and Zatelepin and Baranov did with the optical fiber going around the device, collecting these things to produce a beam, and potentially being able to create new elements from this process, and then pass these, or use stock materials and pass this beam of potentially neutral clusters through these stock materials, and potentially be able to create matter atom lasers and synthesize new atoms and create 3D printers, and ultimately the extension, the logical extension. It's the same level of certainty that I had when I was 15, that by the time I retired, there will be no retirement age. I said that to my parents. Or the same level of certainty that I had when I was writing the documents that went to the various militaries in the UK and the US, that drone warfare, this was in 2000, 2001, that drone warfare would be the completely change modern warfare at some point. it's a certain, I am as certain as I possibly can be that matter wave interference that it appears we're observing and matter wave printing will lead to replicators. And I'll see if I can, before I close out, I'll just see if I can find that presentation called Magic Incarnate, because I really should show you the slide, the thing from John Hutchison. So let me see if I can find that. Give me a few seconds here. If you've got any last questions, that would be great. Otherwise, I have things to do in the morning. Not least, finish the book. Finally. Right. Okay. I think it's in this one. Very slow connection on this laptop. Okay. Yeah, okay. Oh, it's actually on the slide. It's on the cover slide even. Yeah, I think this is something on the cover slide here. So you have three elements here, and you have an increase in one element, and then it almost goes down to zero and it comes up, and then it goes down to zero and it comes up. And then you have an out of phase higher frequency on this element, and then you have a much lower frequency on this element. And this is how it's deposited. So let me see if I can find it in there. Yeah, on this sample under analysis, you got these what look like interference patterns on the structure. Maybe I can. There's something relevant in here. This is a really old presentation, so okay. So let's see if I can find it. So that's talking about Shishkin. Maybe it isn't in here. Oh, okay, right. Go on. Right, so you maybe see here the magnesium is in spots, and coincident with the magnesium is silicon. So on aluminium, you have typically aluminium oxide, and you can see that magnesium, which is carbon and carbon fused together, is coincident with carbon and oxygen fused together, which is silicon. The bridge on this structure is oxygen. Anyway, if you look at this, you get to understand what's going on here. So calcium is only where the silicon is on this particular side, and on the other side, this side, it has iron. So it has iron on this side and no iron and silicon, but no calcium on this side. And on this side, it has silicon and calcium, but no iron. So you can see how matter wave interference is happening on a macro scale, but also on the overall thing here. So this is one of them. I go in a close up with this, and I think I'm actually showing, where is it? Maybe I go, I've got a GIF anime or something here. I think I'm going through. But I encourage you to go and look at this, because it's really showing these little dimples, and then they're kind of semi-regularly spaced, and they have magnesium in the core, and then I think silicon on the outside or whatever. So this is some of my early work that was trying to understand why these particular structures were forming on John Hutchison's materials. So there's that one, but that isn't the one I'm particularly looking for here. I think it's in Magic Incarnate here, if I can see it. Where is it? Okay. Is it a YouTube video? Where is it? That's not it. Have I got the link? Okay, that's the promo. No, okay. Have I actually got it? Okay, here we go. Right, so here it is. It is this particular structure here. So it's like a goes down to a bottomless pit. It's literally like one side of a wormhole, typical image. And if I don't know whether I show the... You can see these lines here and these lines here where the matter waves are interacting. So maybe right at the end. Do I have it right at the end here? Oh, I hope I do. If not, I will put... Oh, here we go. Here we go. Here we go. Right. So on the left here, you see this is where the black hole, the topological monopole was. And what are the elements here? We have, I think, the first one is here is silicon. Okay. What is it? The green one is iron. But you can see all of the different waves here, and the waves are coming and going, but not necessarily always at the same time. So I didn't really understand this. I studied this quite a lot at the time by doing line scans and point scans and so on. I think I even did a image of it. Oh, here we go. This is where it gets interesting. Maybe let me just play this through.
Where do we go?
Yeah, so this is iron, which is on the edges in green. You can see these two spots here. I think this is potassium. Yeah, so iron and copper are coincident. There's these spots of magnesium. Anyway, it's a whole load of elements, and they are effectively like interfering waves around this edge of this black hole-like structure. I don't know if I go into that. Oh yeah, here we go. I'm showing it more. I encourage you to go and look at this presentation.
These are just other elements. The copper. Look where the oxygen is. The oxygen is mostly where the carbon is. Carbon and oxygen.
It's this hard, long, boring work that led to the understanding.
They're slightly here. They're in between.
So there we go. There's the magnesium spots that are in between, and there's clear space between them and the iron and
where the iron is. They're in between where the iron
magnesium and magnesium here with iron.
That is kind of true.
And here we go, the silicon here, but it's not in the exact same place because there's a magnesium one here.
You have this bright area, and we know this has got iron and copper. You have these not bright areas. What is there? We have magnesium spots, but if I put my mouse there and I click there, you've got magnesium spot there, a magnesium spot there. You've got a magnesium spot there and a silicon spot. But the silicon is also incident with the iron. See? Iron, iron, iron. Not there, not there. Silicon, 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 silicon. It's everywhere. It's the same story. It's the same story.
Okay, so
this bizarre, like, waves interfering. You kind of got like, you have a coherent matter wave for
rest my case.
You have a coherent matter wave for silicon, you have a coherent matter wave for magnesium, and some of them interact in some of their phases? Or is it just that there's a resonant combination that's singing a song that's able to create that element at that point? Because if you're making coherent matter waves out of one element, then you would expect when it comes out of being in there, it's going to be one element and they'll all be homogeneous. But if you've got multiple elements in there, then you can't imagine that the silicon would be cohering with the iron, and if it's not completely denaturing the elements to the point where they are not elements anymore, they're like protomatter or the mother of all matter, as Ken Shoulders called it. You could have like the sphere has different wave packets running around it, and one wave packet is all of the atoms of iron that are going in there acting as one atom of iron. All of the is a quantum unit.
Anyway, you can go and have a look at that. So I was basically saying essentially what I was saying today without the level of proof that we have today back in the 9th of May 2021. 9th of May 2021. So 2026. That's nearly half a decade ago. I was saying this, but a large proportion of that was based on what we had observed in analysis of Hutchison samples. And since then, we've seen everything that points to this being a coherent matter process. And so there we go. I rest my case. So with that, I think I'll say buenas noches, dobre noc, good night. This was, if I can get there. Not worked on this. My outro. This was Ode Matterwave Interference. Buenas noches, dobre noc, good night.